Hey guys, it's Miss Adams, and we're going to be looking at the next couple sections here. So we're going to be converting from standard to factored form again. We're also going to be just looking at some different ways to factor. So number 10 says, we're on this Unit 9 test review. Goal here is to make sure that we're understanding how to factor quadratic functions. So question 10 says, convert the expression from standard form into factored form. And it's given us negative x squared minus 2x plus 35. So at negative x squared minus 2x plus 35. Guys, first thing I want to do is factor out a negative 1. The reasoning for this is because we don't want our leading coefficient to be negative. So I'm going to factor out a negative 1 from all three terms. So my GCF is going to be negative 1. By doing so, I'll save that for later. And I'm going to have x squared plus 2x minus 35. So my a value is 1. I got a b value of positive 2. And a c value of negative 35. I know that 1 times negative 35 is going to give me my a times c value. 1 times negative 35 is negative 35. So I got to find two numbers that multiply to negative 35, but add to the value of 2. The factors of 35 are 1 and 35, and 5 times 7. I want them to multiply to be negative, but add to be positive, so I want my larger term to be positive. So in this case, I'm going to do negative 1 times 35 and negative 5 times 7. Negative 1 plus 35 gives me a 34, and negative 5 plus 7 is going to give me a positive 2. So the pairing that I want to use here in this case is going to be negative 5 plus 7. So I'm going to break up that 2x into negative 5x plus 7x and bring down my x squared and my negative 35. Now we can factor by grouping. So group the first two terms, group the second two terms. I'm going to factor out an x from the first grouping, leaving me with x multiplied by x minus 5. I'm going to factor out a 7 from the second grouping. So that's a positive 7. That's also going to leave me with x minus 5. So my factored form in this case, I've got to bring down that original negative 1. And I've got x minus 5 multiplied by x plus 7. Now, number 11 is a little bit different because this is a which one of these does not belong here. So it says circle 1, which is not a factor of 4x squared minus 10x minus 6. So in order to do this, we're still going to have to factor this. So I've got 4x squared. Sorry about that, guys. We've got 4x squared minus 10x minus 6. First things first is they have a greatest common factor of 2. So I know I have a GCF of 2. So I know I can go ahead and eliminate that 2 because I'm factoring it out right now. So it is one of my factors. So that leaves me with 2x squared minus 5x minus 3. And now I can make my ABC chart and A times C and B T table. So we had a GCF of 2, giving us a new A value of 2. Excuse me. A new B value of negative 5. And a new C value of negative 3. So now I've got to find two numbers that multiply to 2 times negative 3, which is negative 6, and that add to a negative 5. I know my factors of 6 are 1 times 6 and 2 times 3. But I want them to add to a negative 5 and multiply to a negative. So I know that one factor must be positive, one must be negative, and my larger factor of the factor groupings must be negative. So I'm going to make the 6 and the 3 in this case negative. 1 plus a negative 6 is a negative 5. 2 plus a negative 3 is a negative 1. So the factor pairing I want to use in this case is 1x plus negative 6x. I can bring down the 2x squared and the negative 3. And from here, I'm going to factor by grouping. So I'm going to group the first two terms, group the last two terms. First grouping, I can factor out an x. That leaves me with x multiplied by 2x plus 1. Second grouping, I'm going to factor out a negative 3, which also leaves me with 2x plus 1. So my factored version of this function, or of this quadratic expression, is 2 times 2x plus 1 multiplied by x minus 3, which means I can go ahead and eliminate the 2x plus 1, eliminate the x minus 3. So the only grouping that works that is not a factor of 4x squared minus 10x minus 6 is x plus 3. All right, the next page is primarily, so we're going to really focus on problems 12, 13, 14, and 15, because once again, we're looking at factoring. So factoring is going from standard form, where standard form is yielding that y-intercept, to intercept or factored form, where we can find those x-intercept values, and we will solve for those x-intercepts in a further unit. But right now, we're going to use some trinomial factoring and factoring by grouping methods in order to solve, or in order to factor these functions. So number 12 says y equals 2x squared minus 1x minus 10. First thing we're always going to start off with when I have a trinomial is my chart here. But looking at these, I don't have a GCF between these values because my lowest coefficient is a 1. So that means I can only factor out a 1 from each of these terms. My a value is 2, my b value is negative 1, and my c value is negative 10. So a value of 2, b value of negative 1, and a c value of negative 10. I now can create my chart. I've got a times c is equal to 2 times negative 10. So I need to find two numbers that multiply to a times c, which in this case is negative 20, but add to a negative 1. My factors of 20 are 1 times 20, 2 times 10, and 4 times 5. But I want them to multiply to be negative and add to be negative, so that means my bigger factor for each of these must be negative. So let's count them up. 1 plus a negative 20 is negative 19, so that grouping doesn't work. 2 plus a negative 10 is negative 8, so we're getting closer, but that one doesn't work either. 4 plus negative 5 is negative 1. So I'm going to break up my middle term from negative 1x into 4x plus negative 5x. So now I've got 2x squared plus 4x minus 5x minus 10 as my expanded expression here, and I can now factor by grouping. 2x squared plus 4x share the greatest common factor of a 2x. So I'm going to divide both of those terms by 2x to yield x plus 2. And then negative 5x minus 10, their greatest common factor is a negative 5. So I'm going to factor out a negative 5, which leaves me with x plus 2. And those are the same thing. So my factored form of this function is y equals x plus 2 multiplied by 2x minus 5. And remember, it doesn't matter which order you write those factors in, as long as they are grouped correctly. This leads us to problem 13, which says f of x equals 2x squared plus 7x minus 4. Once again, we've got a trinomial, so I'm going to go ahead and just make my trinomial chart and make sure I write out my GCF, my a, my b, my c, and I'm going to have a t-table that includes a times c and my b value once again. In this case, my coefficients are 2, 7, and then I've got a constant of negative 4. There's no number other than 1 that can multiply into those, or that's a factor of those. So I can go ahead and fill out my table, my a value being 2, my b value being 7, and my c value being a negative 4. Now, 2 times negative 4 yields negative 8. So I got to find two numbers that multiply to negative 8 but add to a positive 7. I know the factors of 8 are 1 times 8 and 2 times 4. I want them to multiply to be negative but add to be positive. So therefore, my smaller factors are going to be negative in this case. My bigger factors should be positive. -1 plus 8 yields a positive 7. -2 plus 4 yields a positive 2. So the factor pair I want to look at here is -1 and 8. So I'm going to rewrite that 7x as -1x plus 8x. And I can bring down my 2x squared and my -4. I've got 4 terms, so now we factor by grouping. My greatest common factor between 2x squared minus 1x is going to be an x. So I'm going to factor out that x, leaving me with 2x minus 1. My greatest common factor between 8x minus 4 is 4. I'm going to factor out the positive 4, which also leaves me with 2x minus 1. Those factors in the parentheses, those expressions are the same thing. So my factored form here is that f of x is equal to x plus 4 multiplied by 2x minus 1. All right. Now let's look at problem 14. Problem 14 is a special case. I've got y equals 9x squared minus 16. Well, first off, I don't have a middle term. I'm missing that b term. So since I have subtraction here, I'm going to look to see if this is a special difference of two squares. I don't have a greatest common factor as it is currently, but if I look at 9x squared and 16, both of these are perfect squares. So they fall under the case of dots, which is a difference of two squares. 9x squared does have the perfect square factors of 3x times 3x. And I can rewrite -16 with the perfect square factors of 4 times -4. That's going to yield the factors of 3x plus 4 and 3x minus 4. And that's all that you need to show for problem number 14. You can say that y equals 3x plus 4 and 3x minus 4. Last problem we're going to look at for this video is number 15, and it says f of x equals 2x squared minus 8x plus 8. Guys, this is a trinomial, so the first thing I need to look for is a greatest common factor. In this case, I have a greatest common factor of 2. So if I factor out that 2, I got x squared minus 4x plus 4. So I'm going to go ahead and make my chart over here, just like I did with the previous trinomial factoring problems. So I did have a GCF of 2, but now I can go ahead and list out my a, b, and c values. My new a value is 1. My new b value is -4. And my new c value is positive 4. A times c is going to be 1 times 4, which is positive 4. And my b value is a -4. So I've got to figure out the factors of 4. So I've got 1 and 4, 2 times 2. But I want them to multiply to be positive, add to be a negative number. So let's make both of these negative. Looking at this, -1 plus -4 is a -5, so that factor pair doesn't work. -2 plus -2 is -4, so this is the factor pair we want to look at. I'm going to break this into a -2x plus a -2x. And bring down my x squared and my positive 4. Now we can factor by grouping. The greatest common factor from the first grouping is going to be an x. So that yields x multiplied by x minus 2. The greatest common factor from the second grouping, I could remove a 2, but I want that leading coefficient to be positive. So instead, I'm going to divide out a -2, which is going to yield x minus 2 inside the parentheses. Those are the same thing, but if I were to write that out, I've got 2, which is my initial greatest common factor, multiplied by x minus 2, multiplied by x minus 2. But guys, notice, aren't those the same thing, x minus 2 and x minus 2? I could rewrite this as 2 multiplied by x minus 2 squared, since I have 2 of the same factors multiplied by each other. All right, guys, in the next video, we're going to continue on with the Unit 9 test review. We're going to start off at problem 16 where we're looking into some area.